Hello and welcome to today's lesson where we're going to look at concave lenses, which is part of the waves topic in GCSE Separate Science Physics. So if we're successful and we learn in today's lesson, we should be able to draw ray diagrams for concave lenses. So we should be able to describe what concave lenses are used for, understand and describe the different images formed by concave lenses, and draw ray diagrams for concave lenses, which falls into the following part of the GCSE Physics Separate Science Specification 4.6.2.5 lenses, which is separate science only content. So in the previous lesson we looked at drawing lens diagrams for convex lenses. We've got to be able to also draw a lens diagram for concave or diverging lenses. Now these lenses follow different rules to convex lens diagrams, as these lenses cause the light or rays to diverge, spread out and not come to a point. So we've got to use different rules for concave lenses. So like in the previous example of the convex lens diagram, you would draw in your concave lens with that particular symbol, and then you would draw your optical axis through the center of your lens. Now in most examples this is done for you already in the question. So it would look something like this with your concave lens and your optical axis. Now at this point you'd also draw in the principal focus or focal point as F on the optical axis. Now remember, it's the same on both sides of the lens, as the lens is symmetrical, and this is the distance, okay, and the distance between the lens and the focus is called the focal length. Now in most cases again this will be done for you in your examination. Now then you would draw in the object giving off the light as an arrow. Again, either you'll be told where to draw this or this will be given to you in your examination. Now again, remember, the arrow head represents the top of the object and the tail represents the bottom of the object. So at this point you would draw in your object as shown here. So again, the top of the arrow is the top of the object and the tail of the arrow represents the bottom of the object. So the first thing you do is you draw a straight line from the top of the object to the lens. Now again, you always draw this in with a sharp pencil and a ruler. Remember, always to draw an arrow on your ray. Now this is considering the path of one ray from the object. Now any path that doesn't go through the center of the lens goes through a focal point. So what will happen is here is if it was a convex lens, it will go through the focal point on the right hand side, but because this is a concave lens, it will go through the focal point on the left hand side. So what you would do is you place your ruler where the line hits the lens and make sure that ruler is going through the focus or focal point on the left hand side of the lens, and at this point you draw in your real line going away from the lens, which if traced back goes through the focus on the left hand side. This is because a concave lens causes the light ray to refract away from the center. It causes the rays to diverge. So this causes the ray to follow the path as if it was intersecting the opposite focal point, the focal point on the left hand side of the diagram. So it would look something like this. Now at this point you would then draw in an imaginary line going through the left hand side focus. Now this line is dashed as it doesn't really exist. It's being produced by your brain trying to project a divergent ray. So this occurs again because this lens is acting as if the ray is coming from this focal point on the left hand side. So it would look something like this. Now remember again, this line is dashed past the lens because it's an imaginary line. This ray doesn't actually exist. It's your brain predicting where that line should come from. It doesn't realize that the concave lens has in fact caused refraction. It's assuming that that diverging ray has just traveled straight back as such like this. So a concave lens makes it appear as if the light is coming from the focal point on the left hand side. And at this point you'll then draw your second line in. So your second line is a line from the top of the object to the center of the lens. Now like the previous lens, in the convex example, if the ray is traveling through the center of the lens, the ray stays undeflected. So the line goes through the lens undeflected. So if the ray is traveling through the center of the lens, the ray stays undeflected because all of the ray hits the lens at the same time, so it doesn't change direction. So as a result, you've now got your two rays in. Now where the two lines cross, this is where the image forms. Now note, the line comes from the top of the image of the object, so this this will form the top of the image. So the rays cross here and the image is formed here. So you can draw your image in here. Now again, remember the rays are crossing here from the top of the object, so it's for that crossing part is the top of our image as well. So it's very, very important. So the image formed is upright, it's diminished, and it's a virtual image. The image is diminished as the image is smaller than the object, as you can see by measuring the heights of them. The image is upright as the image and object have the same orientation, and the image is virtual as the lines are not really crossing each other. One of the lines is projected back by the human brain. It is imaginary. So there's not actually an image forming here. It's a illusion from our brain projecting that line back. So therefore it's a virtual image. So these are the rules you've got to use when you draw concave lens diagrams correctly. So once you've drawn in your concave lens and you've labelled your focal length and your twice your focal length, remember it's symmetrical on both sides, you place your object in your particular ray diagram. So you have your first particular line, you have your second line, okay, and you form your image. Now remember the first line is a ray from the top of the object to the centre of the lens from the top, and it passes through undeflected. The second is a line from the top of the object parallel to the axis, and this diverges outwards, with the imaginary section going through the focus on the object side, the left hand side of the lens. Now this only exists as the rays are diverging, and where the lines cross, this is where the top of the object forms. So, a lens forms an image by refracting light. In a convex lens, parallel rays of light are brought to a focus at the principal focus. The distance from the lens to the principal focus is called the focal length. Ray diagrams are used to show the formation of images by convex and concave lenses. The image produced by a convex lens can be either real or virtual, but the image produced by a concave lens is always virtual, because one of the lines is always imaginary. You should be able to construct ray diagrams, which illustrate the differences and similarities between convex and concave lenses, and work out magnification with the equation image height over object height. Remember, it's a ratio and has no units, and you can measure the image height and object height in either millimeters or centimeters, and you represent your ray diagrams in a convex lens with the following image and a concave lens with this particular symbol. So if we're being successful and we've learned in today's lesson, we can describe what concave lenses are used for, understand and describe the different images formed by concave lenses, and we can draw a ray diagram for concave lenses. I hope you've enjoyed today's lesson where we've looked at concave lenses in the waves topic of GCSE Separate Science Physics. Thank you very much for listening to today's lesson, and have a lovely day.